Welcome student, welcome to Poor Academy. I am Ashish. Today we will discuss a new topic, that is conditional probability. So before going straight to the conditional probability, we must learn some introductory part which you have already learnt in class 11, and then I will discuss with you the conditional probability, then ultimately Bayes theorem. Then you will realize that these chapters are not very difficult to understand. So let's first start the introductory part which are required to study conditional probability and Bayes theorem. First, random experiment. Random experiment means any experiment whose result or outcomes are known and any of the result may appear. That is random experiment. Like tossing a coin, we know the result is either head or tail and anyone may happen. Or throwing a die, or throwing a dice, or throwing two die. These are the example of random experiment. What is an event? Event means the outcome of random experiment, or the result, outcome or result of the random experiment is called event. Suppose I am throwing a dice. What are the results? 1, 2, 3, 4. So these are the total sample space. 1, 2, 3, 4, 5, 6. So if I say I want even number, so event number, the outcomes of event number. Suppose I want event of even number, event of even number. Then the outcome or result or set is even number in throwing a die. Even number 2, 4 and 6. If the event is getting an odd number in throwing a dice, it will be 1, 3 and 5. So there are different maybe different types of event depending on the experiment. So results of or outcomes of the random experiment is called event. Event is denoted by a capital letter A, B, E, F, like this. Event is expressed by capital letter. What are here we will discuss some different types of events. What is exclusive, mutually exclusive event? Suppose there are two events, A and B. A and B, two events. If two events are such that occurrence of A prevents the occurrence of B, that means if the event A occurred, B cannot occur. Suppose in throwing a die, in tossing a coin. In tossing a coin, suppose A is the event of getting head and B is the getting tail. And A is the event of getting head. If I toss a coin, can A and B both appear? No. So the event A and B are mutually exclusive events. So any two events or more than two events are mutually exclusive if occurrence of one prevents the occurrence of the other. That means both, all or both cannot occur simultaneously. Then the events are called the mutually exclusive event. And exhaustive event. What is exhaustive events? If suppose in throwing a dice, A is the event of getting even number 2, 4, 6, and B is the event of getting odd number 1, 3, 5. In a in tossing a coin, either A or B will come, must come. If I toss a coin, either 1, 2, 3, 4, 5, 6, either it will be even or it will be odd. So exhaustive events means the events, set of events or two events are called, or more events are constitute exhaustive event if at least one of them must necessarily occur. One of them, if I toss a coin, either A or B will appear. So exhaustive event is the events when in a random experiment, when at least one of them must necessarily occur. So the events are exhaustive events. And what is equally likely events? Two events are equally likely if none is expected in preference to other. That means all are equally probable. I cannot predict that its occurrence is more, possibility of A's occurrence, event A's occurrence is more than event B. I cannot say. All are equally probable. That means equally likely events. That means probability of A equal to probability of B if A and B are two events. The equally likely events means the event which are equally probable. No event or none is expected in preference to other event. Then the events are equally likely events. Complementary event. Complementary event, if A is a event in a random experiment, A is a event in a random experiment, it may be getting head in tossing a coin, or it may be at least one head in tossing a coin. Whatever be, A is a event. If in a random experiment, if A is a event connected with a random experiment, then A complement or A dash is the event of non-occurrence of A. Non-occurrence of A. Suppose A is the event of occurrence of even number in case of throwing a dice. Then A complement is the non-occurrence of A event A. That means occurrence of odd number. So A complement, it is denoted by A complement. That means other than event A. That is complementary event, and it is denoted by A complement or A prime. Number 7, probability of an event. This is very common, you have read in class 11. Probability of an event A is denoted by PA, number of favorable cases divided by total number of cases. So NA divided by NS. NA means number of element in the event A. If we consider A is a set, then number of element in set A, and S means sample space, that means universal set, total number of elements in the universal set, that is mean total number of cases. So NA by NS is the probability of an event. Probability of impossible event. Impossible events, the number of favorable cases is 0, so the probability of impossible event is 0. And the probability of sure event, the numerator and denominator are same, so it is probability is 1. And probability of A complement, A, or it is denoted by PAC, equal to 1 minus probability of A. Probability of A complement, 1 minus probability of A. All this I just as a ready-made reference I have listed. 9. Probability of A, any probability must lie between 0 and 1. It must be less than or equal to 0 and greater than equal to 0. It cannot be negative or greater than 1. What is the probability of A union B? In words I can say the probability of at least A and B. A and B, at least A and B, or sometimes you will see A or B. A or B. A or B. So this probability of A union B or at least A and B or A or B is given by probability of A plus probability of B minus probability of A intersection B. And number 10, 11A, probability of A equal to probability of A intersection B plus probability of A intersection B complement. Let's discuss it. Suppose this is a Venn diagram. This is a Venn diagram. This is A and B. So probability of A, probability of B, A is the probability of A intersection B. This part is A intersection B. And probability of B complement intersection A intersection B complement. B complement means outside B. Outside B and its A intersection, that means this region, this region, this region, this region, this crescent, this portion is A intersection B complement. So this section plus this section, this is A intersection B and this is A intersection B complement. This constitute set A. The probability of A is A intersection B plus the crescent A intersection B complement. Similarly, probability of B would be A intersection B plus A complement intersection B. A complement intersection B. So this will constitute probability of B and probability of A. Next, probability of A union B union C, probability of A, probability B, probability C plus minus A, probability of A intersection B, minus B intersection C, minus probability A intersection C plus probability of A intersection B and intersection C. Next, if A and B mutually exclusive, I have already discussed if A and B events are mutually exclusive, then both cannot occur simultaneously. That means probability of A intersection B is equal to 0 because both cannot occur. Intersection means both A and B. So it is not possible. So the minus A intersection B is equal to 0. So A union B is equal to probability of A plus probability of B. So you have read, I have previously I mentioned probability of A union B is equal to probability of A plus probability B minus probability of A intersection B. Since A intersection B is 0, so the probability of A union B is equal to probability of A plus probability of B. Clear? And now in words, if you see probability of A or B or at least A and B, then it means probability of A union B. If says probability of A and B, that means you are asked to calculate probability of A intersection B, both A and B, both A intersection B. And now how we will determine the possible outcome of throwing two dice. Suppose I have two unbiased dice. What are the outcomes? You know, total one die, if you throw one die, there are 6 outcomes, and if you throw two dice at the same time, you will get another 6. So 6 into 6, total 36 ways. So what are the outcomes? Right? That is the sample space. Sample space in throwing 2 dice, sample space of 2 dice. What are the sample space? 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Similarly, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Similarly, 3, 1, 3, 6. 4, 1, 4, 6. 5, 1, 5, 6. 6, 1 equal to 6, 6. So total 36. 36 outcome in throwing 2 dice. And if you toss 3 coin, if you toss 2 coin at the same time, what are the outcomes? Outcome of tossing 2 coin. Head head, head tail, tail head and tail tail. These are the 4 outcomes. And if you throw 1 coin, toss 1 coin, there are 2 outcomes, head and tail, 2. Then if 2 coin, 2 into 2, 4. If 3 coins, 2 into 2 into 2, that means 8 possible ways. So what are those 8 outcomes in throwing 3 coins? Tossing outcomes of tossing 3 coins. So I can take the help of a tree diagram. So like this. First one, tossing maybe head and tail. Then again from head I will get head or tail. Then again from this branch head or tail. From this branch head or tail. From this branch tail, head and tail. From this again head and tail. Head and tail. From this head and tail. And now if I represent these outcomes, so in tossing 3 coins, the outcomes would be head, 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 tail, head, head, tail, head, tail, head, head, tail, head, head, tail, tail, head, tail, tail, head, tail, tail. Then tail, head, head, tail, head, head, tail, head, tail, tail, head, tail, and tail, tail, head, tail, tail, head, tail, 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 tail. 2, 4, 6, 8. So total 8 outcome. You can make tree diagram like this. Starting point, this is starting point, head, tail, from head, head, tail, again from this head, tail, head, tail, head, tail, head, like this. Then you chart this head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. Now, what is the meaning of drawing with replacement and without replacement? Suppose there is a urn or a bag containing some balls. If I take out a ball and then put it again in the previous bag, then I draw another ball, and after drawing I put it again in the bag, and then I draw the third one. So in this way, total number of balls in the bag remains same, because the balls are replaced. So this is drawing with replacement. And if I draw, and in case of successive drawing, the ball are not replaced. Suppose I draw first ball and kept it outside the bag, then I draw the second ball and kept it outside the bag, and then I draw the third ball. In this way, number of balls contained in the box gradually decreases by 1. So it is drawing without replacements. Balls are not replaced in the bag. So let us take an example. Suppose this concept you must know before coming to the conditional probability problem. That's why I am discussing this with you. So a bag contains three white and 5 black balls. 2 balls are taken out one after another. First one ball is taken, then next one is taken out, and second one is what is the probability that first one is white and the second one is black if balls are drawn with replacement and B without replacement. So first A problem, it is drawn with replacement. Then after drawing first ball, it is kept inside the bag again before drawing the second ball. So what is the probability of drawing both the probability of, let AB is drawing a white ball and B is event of drawing black ball. Okay, so first A and B is defined. So what is the probability that first one is white? So there is total in the bag, total number of ball is 8. So what is the probability of getting first ball white? Is 3 by 8, because total 3 white balls and 5 black ball, total number of ball is 8. So probability of drawing first ball white is 3 by 8. Since it is replaced in the bag again, so number of ball remain 8. And then second ball, when second ball is drawn, so number of black ball is 5 and total number of ball is 8. So drawing is 5 by 8. And it is called, what is the probability of first ball is white and second ball is black? So it is a compound probability, A and B, so it will be multiplied. So probability is 15 by 64. Is the first ball is white and second ball is drawn. This is the case with replacement, when the ball are replaced in the bag. Then second problem B, if the same thing but it is now without replacement, ball are not replaced. So first one white ball, probability is 3 by 8, because out of 3 balls total favorable case is 8 and favorable case is 3 and total number of cases is 8. So drawing first ball white is 3 by 8 and it is without replacement. And now when we are drawing second ball, the total number of becomes 7. So the probability of drawing second ball which is black is 5 out of 7. Total number of ball is reduced by 1. So then out of 5, probability of drawing second black ball is 5 by 7. So total number of compound probability of drawing first ball white and second ball is black in case without replacement is this into this. That means 15 by 56. Okay, so these two results are different. So this is the probability, how we will calculate probability in case where with replacement and without replacement. We have to take some help of permutation combination, mainly combination in conditional probability also. Let us take an example. In a group there are 2 boys and 3 girls. There are 2 boys and 3 girls. 2 persons are to be selected. What is the probability that there is at least one boy? So we are interested in selecting 2 persons out of 2 boys and 3 girls. But the condition is, what is the probability that there is at least one boy? So there must be either at least one boy, that means one boy. If there is one boy, so committee of 2, so there will be one girl. If there is two boys, the number of girls would be 0 girl. So these are the 2 possible cases. First, one boy, one girl, or 2 boy, 0 girls. So probability, let A is the event of at least one boy. So probability of A is total number of favorable cases. So favorable cases, these 2 cases, one boy, one girl. So how one boy can be selected? You listen very carefully. One boy can be selected out of 2 boys in how many ways? This is a combination case. So from 2 boys, one boy can be selected in 2C1 ways. One boy can be selected from 2 boys 2C1 ways, and one girl can be selected from 3 girls in 3C1 ways, and there will be multiplication. The total number of cases in which one girl and one boy and one girl can be selected from 2 boys and 3 girls in 2C1 into 3C1 ways. And what is the total number of cases? Total number of cases would be, since there are 5 persons, and we have to select 2 out of 5. So this 2 persons can be selected from 5 persons in 5C2 ways. 5C2 ways. So you know how to calculate 5C2? 5C2 equal to factorial 5 divided by 5 minus 2 factorial 3, and again factorial divided by factorial 2. So this equal to 5 into 4 into factorial 3, and again here is factorial 3 into 2. So factorial 3 cancel into 2, that means 10. So denominator is 10, and now 3C1 means factorial 3C1 factorial 3C1 factorial factorial 2 divided by factorial 1, 2 minus 1 1, and again factorial 1, that means 2 ways. 2 into 3C1 factorial 3 minus factorial 2 divided by factorial 1. So 3 to cancel to 3 ways. This. Okay. So this is the one case. I am just showing you the one boys and one can be calculated 3C1 into 3C2 ways, plus 2 boy and 0 girl. 2 boy can be from 2C2, and from 0 girl 3C0. So this total is sum is the total number of favorable cases, and this is 5C2 is the total number of cases. So we have already calculated 5C2 is equal to 10 and 3C2 2 into 3C1 3, just I have calculated, plus 3C 2C2, 2C2 means factorial 2 divided by factorial 0 factorial 2. So 0 means factorial 0 means 1. So this is 1 into 3C0. 3C0 means factorial 3 divided by factorial 3 divided by factorial 0. Factorial 0 means 1. So this is also 1. So 2 into 3 6 plus 1 7. So 7 by 10 is the answer. Or there is an alternative way, you can say 1 minus all the girls, at least one boy, that means 1 minus probability of all boys. So in that case 1 minus 5C2 and probability of all girls, that means 3C2. Probability of 2% both are would be girl from 3 is 3C2. So all are girls, 1 minus all girls means at least one boy. So 1 minus 3C2, 3C2 factorial 3 divided by factorial that is 3. So 1 minus 3 by 10 equal to again 7 by 10. So 7 by 10, 7 by 10 same. So you can either calculate 1 boy, 1 girl, 2 boy, 0 girl, or 1 minus all girl, probability of all girls. That means you will get probability of at least one girl. So this is the technique of calculation probability which are required for understanding or calculating conditional probability. That's why I have discussed with you. You have already learned these topics in class 11. Now let's start conditional probability.